Now let me show you a practical example. Let's say that this is the results of our experiment where I tried to make a popcorn using preparation times 120 seconds and 240 seconds. And then the second column shows you how many corns actually popped in percent. And then you can see that for 120, I ran this experiment 4 times, and then I got 4 different values. So this is my sample size, right? So let's compute confidence interval only for this case. So it's we are not talking about the effect yet. We are talking about confidence intervals for average outcome for the given level of your factor, right? So, and then I'll show you how to do it in R. So this is the R code. You can see that first of all, what I'm doing here, I create a variable which is called x120. And then you can see I simply combine these 4 values that I have in my second column. So this is my response values, right? Now I compute the mean. So this is my M value, it's the mean. And then I compute also the standard deviation. So this is my S value. And then what I need to do, I need to compute this error margin. And in this case, I already know the t-score for 95% confidence and for 3 degrees of freedom. It's 3 because the sample size is 4, and then number of degrees of freedom we have, it's n-1, 4 minus 1. We know from the previous video that it's 3.18, right? So, and this is why I use 3.18. So this is my t-score times standard deviation, you can see, and then divided to 2. Why divided to 2? Because it's exactly square root of n, right? So remember n equal to 4 in our case, so square root of 4 is 2. Yeah? So this is the error margin. So this is how far average of my sample can go from the average of the population, right? And since now I know the error margin and I know the average of my sample, I can construct the confidence interval as follows. So I take average of my sample and then plus minus error margin. And this is my estimation of the expected mean, but with 95% confidence. So this is confidence interval for average value, average outcome, where I use 120 seconds preparation time. So I expect that the number of popped corns in average will be 32.6 plus minus 3.6. Okay. Now let's do the same for the second half of the experiment. So now time is 240 seconds, and then you can see I have another sample. So it's another population, another sample taken from this population. And then I can do the same, right? So first of all, I combine all these values into another variable, x240. So these are four observations that I got. And then I compute mean. So this is average percent of corns that were popped. This is standard deviation. And then I use the same. So the t-score is the same because sample size is the same and the confidence level is the same. Standard deviation will be different, but the sample size and the square root of sample size is also the same. So this is my error margin. You can see in this case it's a little bit larger, right? And then I can just simply compute confidence interval likewise. So I take average of my sample plus minus error margin, and that gives me an estimate of the mu, of the average of the population. And then I say that with 95% confidence, we expect that the average percent of popped corns, if we use 240 seconds preparation time, will be around 44.5 plus minus 5.8. Okay. So these are both confidence intervals, and now I can visualize this, right? First of all, I can replace the main effect plot that I made before, just in the beginning of this lecture, with this one, right? So now the main effect, I define main effect, it's an average for your sample 1, and then average for your sample 2, right? So in the distance between these two average, it's what we call an effect. And I showed you also these confidence intervals, but remember, these are individual confidence intervals. When I computed these confidence intervals, I didn't take into account that actually these two sets of observations may have any relationship. So these are individual confidence intervals. They just show you the variation, the uncertainty of the mean, but don't use individual confidence interval to compare, to make any conclusion about the how reproducible the effect is. This is what we are going to talk about in the next video.